Hello everyone. Hope you guys are doing amazing. So today we have another beautiful problem from Sweden Mass Olympiad. So before I go through that, this is very beautiful functional equation, and functional equations are always interesting problem to students. So pause this video. Give yourself 5 to 10 minutes. Try your best to solve the problem. After that, replay the video. Meanwhile, if you haven't subscribed my channel, please subscribe my channel and share these videos with your friends. As always, I say in my class, math is not just solving a problem. That helps you to organize your life, get a better decision, and much more than that. Okay, wonderful. So let's do this and solve the problem together. The problem says f is defined from real domain to real range, and its continuous function. It's going to be important. We are going to use this continuous functionality. And this is a relation. F of x plus f of x squared is 0. Okay. Now, what is going to be the general form of f of x? So we should find the general form of f of x. So as you guys are familiar, because we solve some of this type of problem, we start by some numbers to get an idea, okay, to feel, familiar with the problem. For example, if I put x is equal to 0, okay, and evaluate this relation here, we have f of 0 plus f of 0 is 0. That means 2f of 0 is 0, or f of 0 is 0. Okay. How about if I put f is equal to 1? So f of 1 plus f of 1 is 0. Again, so 2f of 1 is 0, or f of 1 is going to be 0. All right. So now this is a time to get better trick to solve the problem. For example, if for x greater than 0, f of x will be, so if you bring this guy to the other side, it's going to be minus f of x2. Then if instead of x here I put x squared, okay, what happens? So let me write it down here. So then minus f of x squared will be, actually f of x squared will be minus f of x4. Makes sense? So f of x is minus f of x squared. If instead of x, for example, you put x squared, then we know that it's going to be minus f of x4, and etc. So you can continue that. Okay, so we got this relation. Now I'm gonna use, instead of x, I put the fourth root of x and evaluate the function. It's possible, right? Because x is positive. So then what happens? We will have f of x is f of the fourth root of x. Okay, and then I can write it down. So note that I use this relation here. Here f of x is minus fourth root of f of x, or plus f of x4. Here, instead of x, I put the fourth root of x. Okay, So then it's gonna be f of x, and here is gonna be the fourth root of f of x. Okay. Now what happens next? If I, instead of x, again I put the fourth root of x, what happens? Then we will have f of the fourth root of x. Okay, it's possible, right? So any fourth root you can put is gonna be the same. Okay, any, based on this calculation here. And if you continue that, so in general form, it's going to be equal to f of 4 to the power of n x. Okay, that means for n is positive integer, right? Like here is like 4, then it's going to be 4 to the power of 2, 16, and etc. And of course, x is positive, real. I can write it down. F of x is f of 4 to the power of n roots of x. That's right? Perfect. Now, if you take a limit, f of x is going to be the limit of f of the 4 to the power of nth root of x when x goes to positive infinity. Based on the continuous function or continuity condition, this is gonna be same as you can bring the limit inside. So it's gonna be f of limit of 4 to the power of nth root of x when n goes to positive infinity. So what is this result? Here, this is important part also. If x is greater than 1 or equal to 1, doesn't matter. So that's gonna be, this guy is gonna be equal to, for example, take a 4 to the power of n and it goes to infinity, so it's gonna be 4 to the power of infinity is infinity. Roots of, let's say 5, 10, 11, something like that. Okay, then for sure that's gonna be based on the limit theory. I'm not gonna go through the details of that. This is gonna be same as f of 1. Okay, and that's going to be, we already calculated on top the value of f of 1 here. You can see that f of 1 and f of 0 is 0. So that means f of 1 here we calculate is going to be equal to 0. Okay, and how about if x between 0 and 1, and what would be the result? The result is gonna be, so this guy in this case, so imagine that, for example, 1 divided by 2 to the power of something, 1 divided by 2 to the power of, or the 4 to the power of n's and roots of half, right? That means you take for example, the you take several of this value, so it's gonna be again equal to f of 1. Okay, so the limit same as here. If it's approach to the infinity, n goes to infinity, that will be equal to 1. Okay, so that means in this case also we will have f of 1 is equal to 0. How about the other case, x less than 0 or negative x? Okay, if back to the original equation, f of x plus f of x2 equals 0, right? So, or it's gonna be f of x is negative f of x2. If x is negative here, right, x squared is gonna be positive, okay? That means you can repeat exactly the same scenario for positive x for this case, right? So instead of f of x, you just put minus f of x squared. For this one is like a new variable like y, which is positive. And then this scenario is gonna be true, okay? That means for sure the function will be f of 1 and it's gonna be equal to 0, okay? Long story short, the final answer is let me go up. The function, the only function that satisfies this condition is gonna be f of x is just 0. Okay, it's the constant 0 value. Okay, take care.